Topologies, protocols, and layers. So first of all, what's a topology? A topology is a map of how a network is set out, basically. Now, there are different types. Now, we've gone through them quite a lot. You've got a bus, star, ring, and the new one they've kind of thrown in is a mesh network. What you've got to think about with a mesh network is that the computers connect to more than just one machine. So if you look at the diagram, usually they connect to each other. So think of like a star, but then connect the machines to each other as well, and that kind of gives you the idea for a mesh. The pros of a mesh network are no single point where they can fail. The con is they're more expensive. And we've talked in class about the advantages of a star network. So the pros of a star are they're very reliable. If one connection fails, so one computer breaks, the whole network doesn't go down. It's easy to add devices to. So you've got a wireless router in your house. Someone comes around, they want to join your network, that's dead easy. I'm going to ring up your internet service provider to do that. You just give them the key, they join on. It's an easy technology to use. It's relatively fast, as each device has its own connection to the switch or server, and there are very few collisions. Something like a ring, if the cable breaks or a machine goes down, the whole network starts to break. And a bus, if that line breaks, the main backbone breaks, the message won't get sent. So the cons of a star are there's a high level of dependence on a single central device. So if that switch goes down in the middle, or that router goes down in the middle, it's game over. There's no other way around that. If the central device fails, the whole network will fail. I mean, the use of a router or switcher is going to cost you more money. The performance of a network will depend upon the specification of the central device. So if you've got a really high-end router, or switch, your network's going to be really fast. If you haven't, it's going to be affected by that. Okay, protocols. Protocols are a rule that govern how devices communicate. Everything in computing is built down or broken down into zeros and ones. So how those zeros and ones get sent around is a protocol. Now, a good example of a protocol is Morse code. So we know that taps and long taps and pauses are used to send the alphabet out and send messages. It's no different in the internet and protocols, to be fair. So let's have a look at a few protocols. HTTP, that is the protocol for how data is transmitted over the internet. It's transmitted in an unsecure format. HTTPS, however, uses encryption. So when you type in a password, you want a bank to be using the HTTPS protocol, so that whatever you type in, that gets scrambled up and is only decoded by the bank. So if someone's sitting there listening on the line somehow, or have hacked into the connection between you and NatWest, or the banks are available, then what that means is that they can't read that message. They don't know what it means. TCP/IP protocols is the transmission control protocol. This is how data is sent between networks. It splits data into packets and then reassembles them, and it checks for errors. That's the main bit of transmission control protocol. So you've got a picture on your machine, you want to send it to somebody else. It effectively breaks it down into packets and is responsible for sending them off. It also checks that all the packets have arrived. So if your picture is broken down into, let's say, 7 packets, hypothetically, have you got 6 packets? Have you got 8 packets? Have you got someone else's packet from somewhere else? The Internet protocol is responsible for packet switching, and we'll look at that in a second. FTP is the file transfer protocol, so that's what's used when you want to upload something, a file transfer. If you want to move a file from your machine somewhere else, we're transferring it. That's the protocol we'll use. POP3 is the latest version of it, or version 3 of it. Post Office Protocol version 3. Internet Message Access Protocol is IMAP, and SMTP is Simple Mail Transfer Protocol. And they're basically the rules about how emails are sent. Packets. So we've said that data needs to be broken down into packets, and think of that like a little envelope. So you want to send a giant poster. You can't send it in the post. You have to cut it all up, put it into little envelopes and send it to somebody, and then they reassemble it. A packet should have the source address, where it's from, the destination address, the packet number, so this is 1 of 50, 1 of 21, and the payload. The payload is the thing inside it. So if you're sending a picture, it might be a little tiny part of a cat. Who's it from? Who's it going to? What number of the picture is it? And what is it? how are we communicating? On the same network, we use MAC addresses, and we've talked about this before earlier on, that they cannot be changed. They're usually 48 or 64-bit using hex numbers, mainly used for Ethernet on a LAN. The MAC address is written onto the network interface card when it's made. When we're communicating between different networks, that's when IP addresses start coming in. So used when sending over the transmission control IP protocol. IP is not linked to hardware. You can have a different IP address on the same piece of hardware. So my phone, when I connect in school, will have one address. When I go home, it'll have a different one. If I go to somebody else's house, it'll have a different IP address. They can be dynamic or static. Dynamic means they change. Static, they stay the same. So the reason why we want to do this is if we know an address for a printer and we want to print to it every time, there's no point in that address changing. Similar to your house number doesn't change every time. That's your address. It stays the same. Websites are exactly the same. Once a website is up there onto the internet, we want to be able to get to it every single time. So the domain name server, when we type in that name, such as Amazon.com, looks up that IP address and it needs to stay the same.